and today at Data Engineering Explorers we're going to explore the concept of data platforms. So we're going to go through where a data platform fit in our organization, what is data platform, what value a data platform brings, what should you consider when creating a data platform, and a basic stack, and also next steps for this basic step. And for our next video, I'm going to do an implementation of this basic stack. This video aims to help any data person that is starting to develop a data platform on the organization they are in, or to understand the general concept of a data platform, what you should consider when thinking about one, and why is it so important. So let's go. First of all, where data platforms fit in an organization. This comes back to you have a product, the developed product, and this product generates data. It has its database data, it has events possibly on like how people, excuse my drawings, but how people click on each like card, or how people search, and you have all sorts of data. And you want to do some analysis. This analysis is quite basic. It's revenue and profit, and like quantity of cells. But you can analyze all of the data that exists, and you also want to do stuff like fancy stuff like machine learning and prediction. Actually, machine learning is prediction, but you want to do machine learning and BI, basically look into the past and predict the future. And you need a data platform for that, because you need data pipelines getting this data and transforming and doing all of this stuff to make available the data for the data product to consume, right? And you have data products that actually create value directly to the business. Now we know where it fits. We will know more about what is a data platform. Data platform may be like data engineering, but sometimes companies have exclusively data platform teams, but usually like data engineering or even data analysts like do this part of the business, data scientists, data people in general, maybe a business person, but not the goal here to discuss that. It is highly associated though with data engineering, and the data platform is a concept, but also like tools that do the job that were conceptualized. And the main goal, as I have previously said, is data pipelines, and data pipelines have the main goal of bringing data to be able to be accessible for the data consumers. But to create a data pipeline, you need a data platform well designed. And to design and create a data platform, you need concepts such as data lakes, data warehouses. You have the shapes and the files and all of these stuff. You have also like the tools. For example, you need a scheduler, you need a transformation engine. Maybe you don't need a scheduler, but for the sake of simplicity, let's go with the scenario. You always need a scheduler. You always need this transformation tool. You always need these parts, and you always need like a query engine to make available the data for the consumer. And to deploy, to use all of these tools, you need some kind of infrastructure. Right now, infrastructure, you can you have the flexibility of cloud. Cloud has like, you have a lot of resources, different resources. You have serverless, but you also have like EC2 that is kind of serverless. We have you have ways that you can allocate servers for your company without having to like buy servers and deploy stuff such as Kubernetes. Also, you have services for that, like EKS. I think it's Google. I don't know. It's not important. The name of the tool itself, but you can deploy it all on a Kubernetes also, or you can use serverless and software as a service to create your infrastructure and to deploy and to use these tools in your data platform. So you have a data platform if you have this concepts that use and create a infrastructure. Next, we have what value a data platform brings to the organization. Like, we talked about tools and concepts and like what is a data platform, data pipelines, and etc. But what is the main value this all bring? Like, what is the main goal of having a data engineer or data platform engineer or data analyst create a data platform? Or actually, what is the value itself? Data, right? You have data products, but you need data. You need data platforms, and you need data pipelines, and you need data engineering because of data. So we should focus on this, because sometimes we forget that making data available for business and products, because products are reversed into business, right? So making data available for business is the most important thing. And what should you consider when creating a data platform? You should weigh in on how much greater practices and like good practices with code and quality, and of course you're going to aim with the highest quality data, but sometimes you don't have any data to analyze. So maybe it's important to have some data and then have strict quality specifications. So you should weigh in, and as I have some experience now, always business wins. So the focus here in this video is to provide value quickly with base features, as I have said. And what are these base features that are needed or to bring data to the data customers that will build the data product? So what is the base feature to do that? And you need to ingest that data, you need to schedule that data, you need to transform that data, and you need to make able to be queryable, that data. You need to store it, and you need to make it able to be queryable. So here we have here in this drawing, I'm going to attempt to explain why you need each part of this as a base feature. As I've said, you can improve all of the parts, and you can add other features as needed, as you will improve your data platform. But looking into a data pipeline that will do only the basics and deliver data, you need ingestion. Ingestion is you have the source and you're going to pull it somehow to your data pipeline, or you can store it here. already and then do like transformation and etc. But the main goal here is to understand ingestion, and ingestion is just pulling the data from its source. And the source itself also can like do a pub sub, if you know it. It can use like events usually do that, but it alerts, have webhooks and etc. that does that too, but you are alerted somehow, or the data is put somewhere for you and then you ingest it. But you should look into sources. You probably will need to look into what kind of sources you're going to ingest and understand them, and like how you're going to do that securely. And to ingest the data, many times you need to schedule it, and actually the whole process you need to schedule it. So maybe I should have started with that, but you need to schedule, so it happens on a daily basis, on a monthly basis, on an hourly basis, or on a second basis. So each second or each minute, this whole task, ingesting, transforming, storing, not querying, but storing and making available, it happens. So you start in the ingestion, let's say at 11 p.m. and then the data is ingested from your day. It is pulled from, I don't know, a database, and you have transformation. Not necessarily you have transformation if you're lucky and the data is quite clean and it is straightforward. You don't need transformation, but many times you need to transform into shapes that make sense, rename columns to make sense for analytical purposes, aggregations, and many of that fun stuff we can talk about for many hours. But after transforming, you have to store. Actually, you can store like at any point, but I'm going to get the scenario that you're going to ingest. Okay, you can store it here before transforming, and then you can transform the data, and then you get you store like in a way that is possible to query this data. So the storage is important for you to have the data transformed, but also to have like historical data from past experiences, mainly to analyze and also to create like models. You need past experience to feed your model, but you need to make available the data. And after like, I don't know, 5 minutes, let's say it's a small set of data, 5 minutes, you have the data available at 11:05 p.m. and your user can query it at this time. So you should consider all of those features that I've just talked about, but what is the basic stack for that? I'm gonna go ahead and say that what is the basic stack actually that the community offers support. Because if you are alone in this situation, which most times I see is true, like one data person at the company or only a few, you need community support because you need forums with answers and all of that stuff. So I would, while considering tools, look into its popularity, because you will need some kind of support. And if you have forums, or if you can ask questions that a lot of people use that tool, if a lot of people use that tool, the probability that you will receive an answer is way higher than if like it's a new tool, etc. So as a new data platform with few experienced people or no experience, I would suggest that even if you have experience, it's easier. So these base features that we are going to talk about in this video and in the next video. I'm going to use Python for ingestion. You have a lot of libraries that connect to many sources, databases, you have APIs and all of the fun stuff. So actually on the next video I'm going to use requests. It's a great library to consume data from APIs. Then we're going to have a scheduler. The most popular scheduler that I know of is Airflow. You have many schedulers such as Dagster, Prefect, Mage, but I wouldn't advise to use them if you are a new person that hasn't experience with schedulers, just because you don't have the support that I've mentioned before. And yeah, I would just consider that. Maybe you are just bold and want to do that, but I would consider that. You have and Apache Airflow is based on Python. So if you have, I think all of these tools are based on Python, but Apache Airflow is based on Python, so it's going to be easy to use Python all the way. For transformation, I'm going to use Pandas on the next video, just because I am not going to go through still on a cluster for Spark or the configuration for Spark. And usually data scientists are more familiarized with Pandas, and it's quite similar actually. If you don't want to use Pandas and you want to use Polars or Koalas or any other stuff, you can use it. But I will use Pandas. And for storage, I will use Amazon S3, but AnyBucket is like the same basically. So I mean, it's just a personal preference, Amazon S3. And for querying, I'm gonna use Snowflake, but I'm gonna only use Snowflake because of its free trial, because other tools that are great for this purpose, such as Athena and BigQuery, I think these three tools, actually there are a lot of tools, but maybe Dremio too. But all of these tools are great for this scenario where you have a basic, you have locally this, and then you have like storage, and you want actually to have like the possibility of using any of these tools, because if you do just this, just like me, and use any other query engine, you're going to have the flexibility instead of storing directly into the query engine. But if you have a preference, all of these tools make sense in this scenario. But this tool is basically just a plug. You can use it as storage too, but you can plug, let's say, into your storage and then query the data. So you have this flexibility, and if different teams want to use different tools, go ahead. But I would look into also the cost comparison between these four, because as you're going to use them a lot, probably, it is important to look into cost. So that's basically it. The idea is to use a local environment for the the ingestion and transformation, the cloud for storage, and some query engine. And it doesn't really matter what tool you're going to use. The idea is the most important part. And we are going to do that on the next video. So, as I've said, the idea is to, in this series, the idea is to create a data platform, but also to improve its value, to improve practices and deliver more value and improve its value. And we are going to build together a high value data platform, the highest value I can provide you. And to do that, after doing the first suggestion that I just said, the first step, this base features, we are going to work with Spark. We're going to work with Lakehouse formats, Kubernetes and CI/CD, observability, open source stack, data lineage, Python best practices. We can also look into other schedulers or other transformation engines, ETL tools such as Airbyte and etc. So my idea is to create this base platform, and this drawing, like, it's basically that, create the base and iterate it together. So we have a high value data platform. And for today, that's it. Please follow us on Data Engineering Explorers and in Twitter and YouTube. If you can give a like and subscribe, that will help the channel to continue. And if you have comments, additional ideas and questions, just please let me know on the comments. That's it. Thank you very much for your viewing.